Okay. Welcome to free online coaching. This is Praveen Kumar Pandey. In today's class, we are going to see some more examples on Newton's law, and this will be most probably last or second last class lecture on Newton's law. Okay, guys. So in today's class, we are going to solve a very famous question of Newton's law, and this question is in Erodo. You will find it in any book. Okay, in any book you will find it in any book. Okay, guys. So here this block is m. Okay, let me give mass 2m. This is m. This angle is theta. What we have to do, we have to find uh, what is the acceleration of this wedge and this block. Okay, what is the acceleration of this wedge and this block. Okay, guys. So here we had. Okay, so we will follow the fundamental procedure. What is the first step? To try to find out acceleration relationship between this wedge A and this block B. Okay, and second step is draw the free body diagram, and third step is write down the equation. Okay, so and how will determine the acceleration relationship between this wedge and this block? With the help of geometry, with the help of geometry. Okay, with the help of geometry. How will determine acceleration relationship? With the help of geometry. Yeah, of course, any question any question can be solved by with the help of geometry. Okay, so who is going to help us in applying geometry? First thing is, my string is inextensible string. Okay, my string is inextensible. And second thing is, guys, this wedge, this block B is not going to leave this wedge. Okay, what I'm saying that this wedge is not going to leave this wedge is not this block is not going to leave this wedge. Okay, it can only travel along this or along this with respect to wedge. It is not going to leave. Okay, it is not going to leave this block is not going to leave this wedge. Okay, so and second, okay, so we had two things which will help in geometry. First is string is inextensible, and second is block not leave the wedge. Block will not leave the wedge. Okay, block will not leave the wedge. Okay, so okay, so let's try to apply this construction on this system. Okay, the string here we have two restrictions, two constriction. First is string is inextensible, and second is block will not leave the wedge. Okay, so let's suppose this guy has traveled by amount x. Okay, and okay, let me call it dx, and this length is x, and this is y. Okay, guys, this is y, and this come down along this by amount dy. Okay, so what is the new length? New length will be, something like this. My new position will be something like this. Okay, my string, it will be something like this. Okay, you got this? Yeah, it will be something like this. So what will be this length? This length will be x minus dx. Okay, and what will be this length? Y plus dy, and this should be equal to, okay, initial length, which is L. X plus y is equal to L. This is the initial length. Okay, so what can I write? Dx is equal to dy. This means acceleration of A Okay, so what it says that acceleration of wave along this should be equal to acceleration of block along this. Okay, acceleration of wave along this should be equal to acceleration of wave along this. Okay, so so I had solved 25%. Okay, now we have to consider that this, we have to now think about this. Okay, we have to think about this. Okay, okay guys, let's suppose okay, guys, here this angle is 90 degree. Okay, and this is x. Okay, and this angle, and okay, this. Okay, okay guys, okay, what I had said that this block this block B is not going to leave this wedge. Okay, so let's suppose after some time after some time this wedge has moved by amount x. So where should be this block, where should be this block? Okay, in this perpendicular axis, what should be the position of this block? The block should be here. Okay, but if block is here, then it will leave it. Where, so what should be the position of block? Block should be here. Okay, if block is here, then it will leave. If block is here, then it will leave. What I'm saying that this block is not going to leave this wedge. So if my wedge has moved, travel by amount x in this direction, so where should be my block? Block cannot be here. If block is here, then it will leave. What should be position of my block? My block should be here. Okay, yeah, think about it. It may take 1 or 2 days. Think about it. It is the important. Okay, you should think about it. What I'm saying, that block is not going to leave this wedge. Okay, if if my initial position of block is here, okay, and after some time my wedge had traveled displaced by this amount, so where should be my block? Okay, one thing it is important to notice that this angle, this is x and this is y, and what is the angle between? 90 degree. So velocity or motion along this is independent from this. Okay, you should note it down. What I'm trying to say, that acceleration along this is independent from along this. Okay, is independent from this. Okay guys, so you should note down. It may travel along this, but whatever amount, but in along this it cannot be here. Along this vertical axis it cannot be here. It must be here. If it is here, then it will leave this block, this wedge. Okay, sorry, this block will leave this wedge. Okay, so to realize this, what I'm trying to say, this, let me give its name x-axis, this is y. So what you should try to think, it may in first look it may look strange, but this is physics. Physics make people strange. Okay, this is physics. Okay, so it in first look to you it may look strange, but if you give some time, okay, you will able to understand it. Okay, so first thing is you should consider that x and y, velocity along x and velocity along y, is independent to each other. Okay, yeah, it is possible, it may possible that my block position along this may be here, but but displacement in y cannot be this. Okay, this cannot be displacement in y. My displacement in y should be this only. If here, then if it travel x, then it must be here. Okay, displacement along y. Okay, you got it. What I'm trying to say, displacement along y of this block cannot be neither less than this nor more than this. Okay, this will be the displacement along y. If it is not happen, then this block will leave the surface. Okay. Okay, so what is this angle? This angle is theta. This angle is theta. So what should be this angle? This angle is theta. What should be this angle? 90 minus theta. Okay, because this total angle is 90 degrees. This angle will be, then this angle will be 90 minus theta. So this is x. What should be this? X sine theta. If this is y, is equal to y. Okay, so let me differentiate this. What can I write? Sine theta is equal to, okay guys, so if you look at this carefully, sine theta, acceleration of A is equal to acceleration of wedge is equal to acceleration of block. Okay, so this. Okay, so here I had find what is the I had find acceleration of wedge, acceleration of block, and yeah, I had find these two things. I had find these two things. Okay, now, okay, there are so many mosquito enter in my mosquito net. Okay, so you got it what I'm trying to say now. So we had solved 50% of the question. Okay, this is the 25 again. We had solved 50% of the question. Now it's time to draw free body diagram. Yeah, it is necessary to draw free body diagram. Okay guys, so, and drawing the free body diagram of this question, people make too many mistakes. This is T. Think about why I had cut this thing here. This is the N1, this is mg, this is N2, sorry, this is N2. Okay, now this is block, this is N. Okay, this is mg. Okay, let me write down 2 mg. Okay, and this is T. Okay guys, so this block will move only along this. It is not going to leave this along y axis. Okay, along this vertical axis it is not going to leave this surface. Okay, so it can move only along this. So what I had taken, acceleration of wedge. Okay, this is the WA. So okay, so this angle theta, this angle will be theta, this angle will be 90 minus theta. Okay, and this angle, this line or this both the force. Okay, if this angle is theta, this angle is theta, this is theta, this will be theta. Okay, okay, so look at the forces along x-axis. I am not going to balance y-axis. Do it by yourself. Okay, I had given so many lectures, so it is your time to do it by yourself. So forces along x-axis is T minus T cos theta plus N sin theta. This should be equal to 2m acceleration of wedge. Okay, okay, now mg minus T, this should be equal to m acceleration of A, wedge. Okay, you got this? Why I had taken this sign positive, this is negative. Okay, now, and what I have one more equation. If what should be the acceleration along this perpendicular axis? Okay, so y, let me wby. So can I write mg sine sine theta, no? Yeah, mg this okay, where this angle is theta. Okay, this angle is this angle and theta. So this will be, yeah, this angle will be theta, so this will be mg sine theta. Okay, so this will be mg sine theta. Okay, you should note down mg sine theta here. Mg sine theta minus t is equal to maw. Okay, and n mg cos theta minus n, this should be equal to maw sin theta. Maw sin theta. Okay guys, so here how many variable you have. Look, this is t and omega. Okay, you had three equation, so you can solve it by yourself. Now I am going to write down this question in one or two step. So if you look at this carefully, if you look this expression carefully, what I get. Okay, let me write down here, no, so that you could see the whole system. Okay, let me write down here. Okay, what can I write? mg sin theta minus ma omega. Okay, mg sin theta minus ma omega into 1 minus cos theta plus sin theta into ma omega sin theta. This will be minus plus mg cos theta, and this should be equal to 2ma omega. Okay guys, so okay, so you should solve it by yourself. Actually here very little page, and here there is no extra space so that I could write here. Okay, and it is very hard for me to see both the pages once same at the same time. Okay, due to limitation of this camera. Okay, so solve it by yourself. This after solving this you will get your answer. Do it by yourself. Okay guys, okay, so let's see some another question. Okay, let's see some another question which is quite similar to this. Okay, so this is block of mass m, this is a small m. Okay, so and I have to find what is the acceleration of this block and this block. Okay guys, so again here one thing is this contact point, this contact point, the contact point is not going to loss. Okay, this contact point, what you mean that this block is not going to leave this contact point. Okay, this block is not going to leave this contact point, first thing. And second thing is Okay, this okay. So let's suppose, oh, and second thing is this string is tight. Second thing is this string is tight. So let's suppose this move by amount. Okay, let's suppose this is the x, this is the x, and this height is h, and this is L1, and this is y. Okay, and this block, bigger block, travel in this direction by amount dx. Okay, travel in this direction by amount dx. So nothing will happen, and this come down by amount dy. Okay, so what is the new length? If you see here, after some time it will be something like this. So this will be my new length. So x minus dx, then h plus this is L1 plus y plus dy. This should be equal to L. What is the initial? And L is equal to x plus h plus L1 plus y is equal to L. Okay, so if you look at this carefully, what you find, dx is equal to dy. What it means, that d2x by dt2, this should be equal to d2y by dt2. Okay, this means that acceleration of bigger block M is equal to acceleration of a smaller block M. Okay, in which direction? In this direction. Okay guys, in this direction. Okay, now what I am trying to say, this contact point is not going to leave. Okay, this block is not going to leave this contact point. Okay, so you know, after some time this will travel by amount dx, so it will be reached somewhere here. So what should be this point? This point will reach at this point. Now what this point will reach here. Okay, so you know what it means, that axle in this direction, you know, this block, a smaller block M, let me give it name A. This block A has acceleration in two direction. Okay, just same manner. What is the acceleration of this block? Acceleration of this block is in two direction, along this or along this. Okay, in same manner, acceleration of this block is also in two direction, along this and along this. Okay guys, so you should be careful about it. Okay, and do it by yourself. Okay, I am not going to solve all the question. It is very simple question. Okay, you could do it. Okay, so you know, and this is okay, I think this is most probably last question and uh, last lecture for Newton's law, simple Newton's law. Okay, uh, okay, I will give you some more suggestion how to solve, how to encounter the Newton's law problem. Okay, after that, okay guys, you know, here if I see my whole Newton's law question, I will divide my question in three categories. First, directly connected. Okay, directly connected bodies, like this manner. You know, this is block, this is block. Okay, and we here will not talk about the spring, body connected by string, or in this manner, like this is block of mass M and this is block of mass M. So here they are directly connected. Okay, there are so many possibility here. This is a block, this, okay, this, and here this. Okay, so they are directly connected. And you know, in directly connected, what you have to think, that they are not going to leave this surface. Okay, they are not going to leave this surface, just like this. Okay, it is not going to leave this surface. Okay, same manner, they are not going to. So here, directly connected bodies. Okay, second thing is, and I had explained a lot of things about in my initial lecture of Newton's law. Okay, directly connected. And second thing is connected by string, okay, so you had seen the how to encounter connected by string. In connected by string, you know, what is the geometrical construction here? They does not leave the block. Okay, the contact point is not going to vanish here. Okay, and here connected by string, you know, what is the key concept, key point which going to help in determining acceleration वगैरह is acceleration etc. is that string is inextensible. String is inextensible. Okay, inextensible. Okay, and how and third type is in which string and directly, string and directly, string and directly, they are connected, they are also connected by string and directly, just like this. Okay, these two blocks are connected by string as well as directly connected. In this case, you know what is the condition? Pala, first is they do not leave, first thing, and leave the surface contact point, and third is surface, let me correct, surface, and third is, second is string is, string is inextensible, inextensible. Okay, string is inextensible. So basically this is the this question is just superimpose of these two. Okay, this condition is just superimpose of this individual condition. Okay guys, so okay, and you know, in some books, in books like SC Burma, you will find some another question like this. Here, you know, you know, for example, this is a pulley, this is a pulley, and this is a block. Here is a monkey. Okay, this is a monkey which is moving upward. Okay, with an acceleration, with respect to this pulley, okay, it is moving upward with an acceleration with respect to this pulley. Okay, you know guys, here you should use the relative motion. Here what you should use? Relative motion, okay, and that's why I'm not going to explain this thing now. Okay, some question you should do by yourself. Okay, some question you should do it by yourself, and if you are not able to understand how to solve it, then comment on my Facebook page, or you can WhatsApp me on, this is my WhatsApp number, 70077191110. Yeah, you can WhatsApp me on this number. So yeah, I definitely will reply. I like to give you answer. Okay, and don't bother, I will not going to ask for money. It's all of these things are free of cost. So yeah, so okay, so you should do it by yourself. Okay, and you know, and I had explained you to how to solve the lift weight problem. Okay, so you should do it. Okay, so this is all about Newton's law, simple Newton's law here, and in next lecture I will started to explain friction, etc., so that you are okay. Friction, in next lecture we will see, we learn about friction, how to encounter friction question. Okay, after friction then we will learn about circular motion. Okay guys, thanks. If you like, then you can subscribe my channel, and what you have to do, you should find free online coaching. Okay, you should hear his title, after below this title you see free online coaching, and below it you have to in red color it has written subscribe. Okay, click this tab, subscribe tab. Okay, and what happened by clicking it, you know, whenever I upload the video you will get notification about it. Okay, whenever you open your YouTube, whenever you open your YouTube account. Okay guys, and but what is the necessary condition for it, that you have to log in with your email ID. Okay, you have to log in with your email ID. Okay guys, so thank you for watching, and subscribe us. Okay, your subscription motivate us to make lecture. Okay, thank you.